In this video, we are going to go over some practice problems for this worksheet, which is going to be the classwork for balancing half reactions. So I'm going to do, there's really two types of problems. I'll do one of each and then one harder one. The first type is where they actually hide the parts of compounds from you. That's problems 1, 2, and 3. So if you look at these, like for example, number 1 I did in my first video, so let's go to the second one. In this one, this PB is part of a bigger compound. They're just intentionally not showing it to you. Now, in order for you to be able to get an oxidation state off that, they have to write it in for you. So that's why they're telling you this PB is +2. It's not that they're being nice. It's that if they didn't show you the whole compound, you couldn't figure it out. But if they showed you the whole compound, you could also balance this equation through a different, easier method. I guess that's the point of view, but I think it's an easier method through like the traditional balancing. So there's a kind of a give and a take there. Like they're trying to force you to use a redox balancing method, and by doing that, they have to give you the oxidation state because there's no way you'd know it on your own. So here's what we do. First, don't put all ones. That's your number one mistake. It's never all ones. It's almost never all ones ever. Okay, and in these equations, it's almost never all ones too. You're gonna have to figure. I mean, it might be. Don't get me wrong. It could happen, but you have to figure that out. Don't just write all ones and think you're done. So the first thing we do is we connect the elements that, and I don't care if you point from here or from there. It doesn't really make a difference. You connect the elements that change. Okay, and that's still really easy because there's only two elements in this equation. And then you figure out what they did in order to change. So Cr went from 0 to +3, so that means it lost 3 electrons, which means lose electrons. It was oxidation. And therefore the other one must have been reduction, and in this case, it gained 2 electrons. You do not have to lose and gain the same amount. In the end, you're going to have to balance it to make that gain and loss be equal, but it doesn't have to be equal right off the bat. So now let's write out the reduction reaction. So this is what it looks like. PB +2, gain 2 electrons. That's why I'm adding them to the left. Turns into PB0. All right, so that's the half reaction. Now the other one is going to look like this. Cr0 turns into Cr +3, losing 3 electrons, and that's why they're on the right side. And now to balance them, I'm going to go to their first common factor, which in this case is going to be a 2 and a 3. All right, so those are the first common factors. That makes the gain 6, because 3 times 2, and the loss 6 for the same reason. Now, I take these balancing coefficients and I put them in the balancing spots. So the CRs get 2's in front of them, and the PBs get 3's in front of them. The reason they give you these types of equations is because this balancing works. When you get a more complicated, or the whole equation, I guess you could say like 4, 5, and 6, the problem is you can balance them. You could balance them the traditional way, balancing the elements on each side, and you could get the balancing coefficients more easily. And so they're basically trying to force you to use this method in order to do it. For example, I'm going to show you number 6. So number 6 looks very hard. It's not. So there's lots of options here. So the first thing you're going to do is assign your rules. When H's are in compounds, they're +1. So you put a +1 on all the H's that are in a compound. When oxygens are in a compound, they're -2, so you put -2 on all the O's that are in a compound. Elements are 0. The only element here is this S when it's alone, so it's a 0. And then you just have to figure out 2 N's and an S, and you're done with this part of it. So in this case, you get +2, +5, and -2. Now we're going to only focus on the elements that change. So the elements that change in this case are going to be the S and the N. It's that simple. So what did S do? Well, it went from -2 to 0. So that actually lost 2 electrons and was oxidation. Therefore, the other one must have been reduction, and it gained. In this case, it went from -5 to, no, sorry, it went from positive 5, my lines were a little weird, positive 5 to plus 2, which is going to be gaining 3 electrons, all right? So let's make sure we, there, makes it look a little better. So that one is going to gain 3. So let's do reduction first because it's on the left. So in this case, N was plus 5. It gained 3 electrons, so I'm writing them on, I'm adding to the left side, left of the arrow, and it became N plus 2. All right, because plus 2 is more towards the negative than plus 5. And then sulfur lost 2, so the 2 that get lost get added to the right. Now, here's the problem. When we do the balancing here is easy. 3 and 2, their first common factor is 2 and 3, and they go to 6 as their greatest common factor. 2 and 3 are their multipliers. The problem is you can't just take this 2 and 3 and now plug them into the equation for multiple reasons. One, not every there's multiple equations, compounds that have N's in it, and there's multiple compounds that have S's in it, so it's not that simple. It worked for the first 3 because these were oversimplified chemical reactions, but it does not work for more complicated chemical reactions. So if you were to balance this one, the balancing on this equation would be 3, 2, 3, 2, 4. So if you look at those, the N's don't all have, well, I guess the N's do have a 2 in front of them, and the S's do have 3's in front of them. But again, that is more of a coincidence than anything. It doesn't have to be that way, so don't just assume that. You can only do that for these reactions. It doesn't always work. So just be aware of that, and that's basically as hard as it gets. If you can do 6, you're pretty much set. I am going to do 1 on the back of this page. Yes, there's a back. And the reason is it's a little bit more complicated than what you've seen. So let's go do them. So let's look at, which one was the one that I wanted to do? 8. 8 has a tendency to throw students off. I'm not going to do the whole problem. I'm just going to get it set up for you, all right? So the rules. H's are +1 when they're in compounds. Oxygens are -2. Elements are 0. So that's everything. Oh, there's another one. So those are the rules. Now we only have 2 S's here, right? So this S in this case is going to be, let me see, +4, right? And this S over here is going to be -2. So now if we look at the elements that change, the most common thing students do is they say, well, only one element changed, S. And that's 100% correct. Watch. S went from +4 to 0, but it also went from -2 to 0. So whenever you have loss, you do have gain. It does not have to be the same element. This is a rare example that does this, but I just want to show it to you. This top S went from -2 to 0, so it actually lost 2 electrons, and that's oxidation. But then this bottom one went from +4 to 0. It gained 4 electrons. That's reduction. So your 2 half reactions in this case are going to be both with S. All right, so that's what I wanted to show you on number 8. It throws people off because it's usually the first time you've seen something like that, but that is an option. Okay, there are a couple other things I need to mention on this video. So let's see. There are some problems here that I didn't go over, like for example on number 11, you have rules for K and O. H you have a rule for, so this Cl is not going to be a problem. K you have a rule for, so this one's not going to be a problem. CrCl3, you have no rules for these. This is an assumption, but it's going to work for this problem. We're going to assume the Cl is -1 in that instance. This one you have a rule for, this one shouldn't be a problem, okay? And for number 12, there are some assumptions that we're going to have to make here as well. We are going to have to assume that the S is -2, and in that example, and then we are going to assume, actually you don't, it's just that one problem. This one you have no rules for either one, so you can't solve it. H2O2 is an exception to the rule, so I'll give you a hint on that one. This one, it has to be done in 2 steps. You have to solve for the S before you get the PB, and then that's regular H2O. So those are just some of the exceptions in the video as far as, or I should say in the problems where you have you needed a little bit of outside help for. But it's only those. The rest you have rules for, like, for example, K is in group 1, so you have a rule. So you know K, you can find CL. And the same thing here. You can figure, you know, if a rule for K, a rule for rho, you can figure out CR. So you can do all these. It shouldn't be too big of a problem. And that concludes the video for this worksheet. There will be an answer key with the final solutions available at some point.